Okay, so I think we just move on to the what we are going to cover today. So, like I said, yes, we'll be doing something on demand, on forecasting. It's applicable on maybe on not from the topic of today on demand forecasting, but it's also a tool that you can use on very many different types of data, specifically on time series based data. So that's anything that you're collecting on a time base. So for instance, the guys in production here, so it could be numbers or how many are you producing on a per hourly basis. It could be sensor data, you're monitoring conditions on some equipment. So all of those kind of things, provided it's time-based, or it could even, and by time it can be minutes, it can be on a week basis, hour basis, per day. Okay, so yes, so those kind of data, and what you can see like here is our switch off. So we have different methods we're going to use. There is linear regression. I think this is the first thing you learned when you started learning about data science. So I don't think we learn or do so much on that. So we'll instead start from moving average, exponential, autoregressive, uh, uh, these also called ARIMA. The short form for that is ARIMA. This holds winter season method. If time allows, we'll actually do that, but I thought we do this for the one that I've bolded out are the ones that we are going to touch on. There's another one called Facebook Prophet. The sarcasm there is amazing. So yeah, but it's actually forecasting. And then there's also deep neural networks. So this probably will come sometime in future. We haven't gotten yet into deep learning. So when we get into deep learning, then we'll actually be able to use this as well. But all this, they've also been arranged in increasing complexity, and they, like when you start from, is not able to do. I'll try use different platforms. So what I have prepared today is we'll do something small on Excel, but we'll see there's limitations of that and also how long you take to do that. So we'll move away from Excel and then now get to actual coding. So and also if you have any question, just ask a question. So we'll start with this one. So moving average, this is one of the, it's a pretty easy concept. And basically it's like from what you're seeing from this graph here, the blue graph is what maybe you'll actually be, is your address, is the actual data. And then with moving average, you take like a certain number. So this is a statistical formula for that. So it could be the first number or to whatever number of iterations that you're going to take. And then you take the average of that and then use it as a point. So what happens is it will start sometime later in the graph. So for instance, when you're doing only two numbers, so it's also called a rolling average, average. So you'll actually be moving with this. So you'll start here, move with it, and so you eventually when you do the plot, you end up with this. We can have a look at this on Excel. I think this and maybe I don't know how much you've interacted with Excel, but Excel is also, with the right hands, it's also a very powerful tool. So you can also do a lot of things with this, but it has its limitations. You'll either take too long, or you'll neither to take too long, or so if you check there's the drive folder that I've shared right now. It has some different data sets. One of the data sets that's there is this one on female birth rates. This was some time back from 1959 all the way to, I think this was for the whole year. So they were recording that on the different days and seeing how the numbers are changing. So for moving average, for instance, if you, like with Excel, just, if you were to maybe just do a simple one, where we're doing a moving average of 4. So this will be, you just take the average maybe of the first 4, and once you have that, then you maybe copy now all of that to maybe a certain value. So what happens is this also maybe it would be good if we could plot this. So what happens with the, so if we plot this, you'll end up with a graph like this. So this is for the actual data. Then if we add the next thing, that's a moving average, it sort of smooths out the curve. So when you have spikes, so the good thing with this is it's a good tool to use when you want to avoid rushing into maybe for the guys in sales, you might see a spike in sales and you immediately want to push more product, and you need to maybe observe a bit and know when to react. So this, especially like in if you do forex trading or stock trading, this is actually a good tool to even help you know when to move, when to do a specific, maybe when to buy and when to sell. So for instance, here we are seeing like we do a moving average for probably maybe a week, or this is actually in months, and you do maybe every 10 or 20 days. So before you rush into buying on something, you want to really confirm. Moving averages will help you confirm that you're actually maybe moving to a certain trend. They help point trends. So for instance, in this one, they're actually using 2 of them. So with 2 of them, you're actually able to tell that you'll know when to buy, when to sell. And normally they'll do like 2, like, so when these 2 cross and the actual graph is on the upper side, then it's a signal that you should actually be buying. So if you buy, then, and if you've actually followed that rule, then here you'd see you'll make quite a bit of profit moving up with this all the way to the end. And at this point, then you know that you're supposed to maybe stop buying and cut that off, and you make your profit, whatever that will be, the margin from here to here. That will be a happy day to whoever will be trading, right? Any comment, question? And go back to the Excel. Any comment or question? So back to this. So for instance, with this, we're doing just with a simple moving average of 4 values. So it is so first we'll maybe, once you do this, you'd want to check the error that you're actually getting, and this you do with maybe like checking the difference between actual and because this is more like a predicted, like you've seen from this graph, it's predicting the next value that should have been here. But obviously, like you see, there's a difference between this and this. So it predicted this number will be here, but the actual number was here. So so we can do maybe check on the errors that it's actually coming up with. And so these also, like we will see from you'll see from the way we do in Python, we check the error. Once you use a certain model, you want to see the accuracy of how it's doing this. So in Excel, you do maybe like check the absolute value and the difference between these two. So this will give you the error that's coming up from that. And then also with this mean standard error. So this you'll get through doing a square of this. So mean squared error. So you do that, and then you actually get just now the square root So you can see with this, so the square, now this will be the square root, and since it's the mean, you do average as well. And now the average of all the errors. And then also from that, you can also calculate the percentage error, which is now the difference between this and this. And so if you're using maybe like a moving average of 4, you end up with this. So this is usually a good tool. It works sometimes, but the other problem with it is if, for instance, if we have a big spike, if we have a big spike and it always reacts to the big spikes. It will always react to the big spikes, so you might end up doing, if you react too soon to that, you'll end up doing a mistake, which could be very big. So this, it's a good tool, but it's not, it has its problems. It's for data that does not have very big spikes. Next one we have is this here. Okay, so the other one that's there is, it's called an exponential moving average. So this one helps as well. It's more like helps to counter some of the problems that you get in moving averages. So next one is this. So with coding, what you'll find is it gets really easy. You see, like in Excel, we were doing a lot of calculations just for a very simple thing. When you're doing it now with code, there is all of these functions are already done for you. So it gets quite easy. So in Python, I think I won't go through the basics. I think everyone here has gone through the basics of that. But if you have a question, just give, you can just tell me. So I have, within that file, there's also quite a number of, data sets here. So is this, we'll use different ones. I'll challenge guys to analyze maybe this one and this one from the methods we're going to use right now. But for now, with Python, it's kind of very straightforward. So we start. So here it's just simple data importation and just analyzing to see what the data looks like. So for instance, for this specific one, this is what the data looks like. It's the oil prices since I think 1939, and for when you're coding this in Python, it's very straightforward. There's this function here. So this is called a rolling average, like we said in the previous section. It's still the same thing, moving average, rolling average. So here it's called rolling, but then you have to specify the period or the number of items that you're going to analyze or average. So it's going to roll, for instance, for this one, it's going to roll every 5 values. So it's going to do a rolling average of every 5 values, and we can actually overlay this on the previous graph, and you can actually see. So over time, it will have 5 or 10 window period ahead of what you're actually viewing right now. So a point where maybe you'd be trying to, or you're asked to speculate, forecast how many sales you're going to have next week, based on what, so you'd analyze based on the previous sales you've had for every week, and this would give you maybe 5 more days ahead, and you tell what amount. So like from a production, there's someone from production here. So if you're being questioned on how much should you produce, and so this is probably what the planning department will be using, and or even maybe now for Wellington with maybe predicting, if you're trying to check how much you're supposed to produce, maybe, or you're analyzing your day, how people use the electricity of a whole day. With this, you'll be able to do that, to know and predict even when's the best time to do maintenance on equipment. So yeah, but this also, so the other thing you'll notice is depending also on the data we use. So this is perfect, and it's perfect for almost kind of like a regression kind of setup. But when you're analyzing, you'll see here there's like a cycle that's happening. So like these spikes at a certain interval. So sometimes you wonder why. So or like in the real world that we live in, these cycles that are usually there. And you'll see that with rolling average and also like with exponential, even with exponential, it's able to take care of that, but still not as good as, it's still not able to take care of all of these other aspects. There's a trend that's happening. So you might actually be on like, for instance, for most companies, when you're approaching December, the sales go up. So you might be there patting yourself saying that I've made sales grow, yet that is the normal trend. So you should be able to tell the difference between normal trend and also when you're actually growing. With this, when you're using these two methods, they not be perfect, but that's why, so we end up using more. So any questions, please?
Yeah, there, yes. For me, I haven't been able to implement this.
Yes.
And like I had mentioned earlier, we've been basically using a lot of Excel, but yeah, we have something to try to start. We have some homework actually, if I may say that.
Yeah, so it's good. So this, you can actually, the good thing with this, like you can imagine, like if you're doing the same thing with Excel and you're trying to, so the other part I didn't show is, okay, like I said, since you're getting 5, you're doing like a moving average of 5 and 10. So you'll actually be seeing 5 days ahead.
Okay.
So what actually, maybe this, for this graph, you're not seeing, but this, the moving average is ahead of the actual graph. So you'd use that to actually maybe predict what you're going to, and also I'm sure you'll get asked questions on how much should we produce, so that maybe you're not rushing. So that you'd use that to tell how much they should actually produce, and you'd find yourself not falling short on how much you're supposed to produce. So that, so it's usually an easy one, but then maybe depending on the other factors that will come in, and then things will go a bit
excuse
chaotic.
For other factors, so this is just the basics. If you just have, for example, the month and sales.
Yes, and also actually, like, I get where you're coming from. So the other thing is the methods we're using here. So when doing forecasting, we have different methods. So there are two things we normally do. We have univariate data, or like univariate data analysis, and then we have multivariate data analysis. So yes, so some instances, or even what is actually there, is that most of the time we are affected by different things. So maybe from a manufacturing point of, for a machine, only one thing might be affecting it, like its temperature versus speed of the machine, right? So that one, this method, these two methods will be perfect in such situations. But for multivariate data, like where you're being affected by maybe temperature, in Kenya, the weather seems to affect everything. If it rains, there are things that go up and down, and so like there's a lot of things that happen dependent on weather, and so many other things. So there's you remember PCA, principal component analysis? Yeah, so that's one of the, sometimes you can have, like, I remember when I was doing analysis on the wind turbines, I had a data set that had 200 different components that affect one of them. So yeah, so in such a situation, like maybe we're not touching so much on this, but we do now the PCA analysis and end up with like 5 of the biggest components that actually affect this, affect the figure you're trying to analyze. So once you do PCA, then you'd end up with 5, and Then depending on the method you use, this tool will not be very applicable. This would be generalizing that. But now the other methods that you're actually able to integrate all the other components. And it's able to, so like I think with Facebook Prophet, you'll see how it's doing that. So it's quite, so it's able to do that and go like try to account for everything. And like you see in the video I had shared, what they say is they're trying to be better than any human. So provided the solution you come up with is doing something better than any human that exists, yeah, probably there's no one who will be able to beat your system. So just yeah, so that I've answered your question.
Yes.
Okay,
James.
James.
Yes.
It's James Kimani.
Yes, that's me.
Oh, okay. So if you just go up a bit on your screen, like the code.
Yes.
We have the span, not this one, the other one. You have the span here. Exactly here. So
yes.
Where you have the span, that's where you actually
yes. So now, for instance, for this one,
yeah,
this is now for exponential moving average. Yeah?
Okay.
Moving average. So this is for exponential moving average. So there's the documentation for Scikit. There's a lot of functions for the mathematics that happen in the background. So this is the one used for this, for exponential moving average. So, but also now you can also specify this. Sometimes I think for like Grace, I think you can advise, you know when to use. There are times when you use median, mode, or mean. So you have the option of changing that as well. So with this exponential, you can actually change that. So if maybe you're trying to just analyze and see which is better, so you could actually change this. But there's this like this one, especially when you're using Python. This one, the documentation has been done so well and so detailed. It's one of the tools that you should always keep close to you. So if you're using something and you're a bit lost on maybe what's happening, this is one of the really good, like they even have. So you can come here, look for a specific function. You'll see how it's being implemented. Use a random one, not exactly necessarily the exact same machine learning. So each function has what we'd call hyperparameters. So for this one has span as one of its components, and also there's adjustment and there's adjustment. And you'll find there are default values, but you'll find that they can be very many. Some have even 10 or more values. Yeah, so you see like this one. So this is the function that maybe you'll have used, but then there are all these components that are here. When you're using it, when coding, you don't necessarily have to use all of them, but maybe you want n components to be a different figure. So these are the default figures that will be there, but for this function, you will want it to maybe be, for us, maybe we change it to 5. Yeah, so that's basically why there's that here, which you can change it and see. So for instance, here, like I've used 10, you can try 20 and see what the graph will look like. The next section is also quite interesting. So this one helps or tries to account for the other aspects of that could be affecting how a chart maybe looks like, or how your figures are actually looking like. So there is this concept called autoregressive integrated moving average. So it's a big name, but it's basically can be broken down into this. So it still has a moving average component within it, but it has an integration. I think for probably the guys with the technical background, there's something we use in control systems, there's something we call PID. So this is almost an equivalent of that. So first, so there's the first section, autoregression. So a model that uses the dependent relationship between the observations, and then there's an integration component. So these, like you've seen in the previous ones, if there's a spike, then everything, they can very easily be give you the wrong figure, or they'll give you you'll end up seeing something that is not actually there, or you'll end up, if you follow the numbers, you could end up giving the wrong decisions, and probably it was just a one-time spike, and children have just been ignored. So with this, it tries to help account for that. And when you're using it on Python, they have different components. So it has, like the same way we've just looked at the other one, it has different components. There's this P, there's D, and then there's Q. And then also, so this, and then there's this other one called Sarima. So with Sarima, it has 6 of them. Just this one's in capital, but this one is usually trying to account for seasonal as well. Because like you see, especially when you're looking probably like at several years, there are times when, like depending on the company, you'll have seasons of a whole year, or maybe it's every quarter. Especially maybe like when you're looking at season, maybe you might have semi-annual cycle or season. Maybe for most companies it's an annual one, so you'll add this. Yeah, so with this one, so I think the challenge I'll have first is we have to change. So we'll change to a different one and see maybe how everything is. So the other thing you'll see is all the data we're analyzing is time-based. So every time you are analyzing this kind, or the data we are looking at in this time series, you'll always have one column that is time-based. It could be minutes, it could be day basis, month, or yearly basis. So you always have to convert this column into a time series, and then once a time series, and also set it as the index. Best way when you're starting, just try do a chart. Also, okay, there is a problem I found in this one, but you're supposed to have this arranged chronologically. So this one only had a number and only the month alone, but you can actually separate this. There's a different data set I have. You can separate the different columns into months alone. So this one had this number that is actually not, it's not a date and it's not an year, but you have to change this to that. And then, so once you do that, so this is just to do observation. For some reason KPLC have, I think this is where one of the components they should be using, because I think very many people are at home now, and electricity is being used more during the day than it was being used in the past. Normally you get a drop during the day, right? Slightly, and then slightly maybe past 5, around from 5, then it starts going up. Maybe during the day it's the industries that are using more. Wellington, maybe you can tell us more on that. But
actually, the peak demand for the country starts at around 5. Yeah. That's where KPLC experiences the demand that is so high, around 800 megawatts, yes, to around 9 to 10. And again, it drops when people are working for dawn around 4, again it goes high. Then it comes up to around 10 in the day. Then from 10 to 5 is that industry is running, so the demand goes a bit lower.
So maybe like a brilliant application of what we're doing today will be having such a system automated. So maybe there's also like when the other supporting power plants come in. I don't know the level of automation of that, but with what we're doing today, you'd have monitoring, you'd be analyzing, like now the simple one we've done right now with the moving average, you'd be able to predict, or even with the ARIMA, you'd be able to tell the next, how now the season in this will be on a day basis. So how the 24-hour season normally, the 24-hour trend normally is. So it will now exactly what you've explained. So it will move up and down. So there is when, and the switching on should be automated. So that's the other part. So maybe like for the sales guys, there is where you should be, okay, there's basically you should just have an automated system on switching on and off. But anyway,
actually, just to comment on this, because I'm also learning something here, because around 15 to 17% of the grid is dependent on energy which is renewable. That is wind and solar, but the biggest challenge is actually forecasting.
Forecasting,
yes, actually, that's where the point is, because you need to actually predict and tell them that in the next 1 hour, this could be available. So I think that's where I'm learning something from this session.
Yeah, so here is very much applicable. And even when we now go down to so now as we go to ARIMA, so the moving averages are not as dependable, especially like in such situations. But when you start going into ARIMA, and now this is on Facebook Prophet neural networks, you can actually tag a machine on that and you actually fully automate it. Like, so like the way I do it at work is I've done a similar thing where if a machine has 90% confidence in doing a certain action, then a human being should not be there to do it. It's not like he'll be more certain than the machine, right? But maybe where you're 70% or 60%, the certainty is around that, then that's when a human being should come in to make the decision. Okay, so any question, comment from anyone? I hope you're seeing where you can apply so far where we've gotten.
Yes, we can.
Yeah, so the other one, sometimes I kind of call it, in those who've attended my previous sections there, especially when you go to neural networks, because you put in something and something comes out and it's correct and you are unable to question it, but yeah, it's actually correct. So yeah, but and even maybe one of the fields that's coming up right now is, I don't know if you've seen articles or blogs on explainable artificial intelligence. Anyone who's seen something on that line?
Come again?
Explainable, like they call it explainable machine artificial intelligence. Because what's happening now is you have people who will code and they have the correct answer. I think that used to happen maybe in high school where you have the correct answer, but the teacher is like, how did you get to it? Because you'll now come with the brilliant solution or how things should be done or what should be maybe the figure to be done, and then someone asks, how did you come up with this number? Did you just guess it? Yes, you used a formula and a formula or some very complex neural networks and you came up with a solution and it worked, but you have to explain how you did that. You have to explain how you did that. So that's actually, so there's different functions that are actually coming up to even help explain the different steps that's happening within a program, within like a function that you use notebook. But for these two, so what you'll see with this, especially like with the bigger model on the Prophet, that's where the complexity of what I'm explaining right now on explaining comes in. It doesn't, so like this is actually everything that's happening. So with this actually, and it's actually specifically just this one line, but in the background there's so many things happening. So maybe reading more on, if you are to read more on this, on how what's happening in the background, because this is actually a really good one, but you use it and you'll start being questioned. Yes, you have the right answer, but how did you come up with it, or what was the result, or how did you get it correct? And because maybe we want to replicate it again. So yeah, so like with this, so for instance, is there anyone here who follows stocks? Especially maybe the Dow Jones, the S&P 500, in Kenya and maybe in US as well.
No.
Kidogo.
So okay, so but basically this is what's been happening. There's this company called Tesla, and this has been the trend since some time back. But what happened since sometime last year? From last year, it's moved almost, I think this from 200 to 800. That's like 400% increase. So the black dots show the actual value of the stock. They show the actual value of the stock. But then around here, early this year, coronavirus happened. And it's dropped. Right now, it's even almost at 200. But when you use Facebook Prophet, this is what it's saying. I don't know. Anyone with an opinion on this? So like what? So this is what it's saying. 2021. This is what will happen. So so the models, and even I think there's some time back I asked this question, like when you are data scientists, you'll actually do a lot of analysis and come up with a recommendation or insights. But from the way it looks, it's like people don't even believe what they come up with. Especially like the one I shared was on coronavirus. 4 years ago, a similar graph was done, and that was now from Microsoft. They said we are definitely going to have viral, that's smart, and or it was more of they can't explain. So should you ignore this? Just a comment from anyone. Those who are too quiet, I think I'll just pick them up. James from Cooper. Comment. So when should we ignore the analysis that you come up with, and what's even the point of you doing the analysis if you're going to ignore it?
Actually, you just tell them, and you've already done your part when you do analysis. So them believing and taking measures, actually.
So in this situation,
Yeah.
Maybe just a span I'll throw at this again is, this is you to decide now. It's not even someone else to decide. So you are the one investing. So everything is pointing down, but this is telling you buy. What should you do? Because now it's not even based on someone else's decision.
Okay,
You don't believe in
maybe
what you're doing.
if I'm okay, maybe take necessary precautions, like maybe like right now, as in historically, if we can use the case of
Mhm.
the coronavirus, like such stuff have like the second wave and nini, so we just prepare for it, and
Yeah.
so that when that situation arises, on how to deal with it in the best way.
Yeah. Anyway, it's just a challenge to everyone, and because what will come up with is you'll now be using data science to make decisions, and there's a day it will challenge you to make a decision that is against the norm. So do you follow it, or are you just playing with numbers that when it calls you to make the hard decision, you'll not do it? So especially
I
like
think
in this, you actually accounting. So like what Grace had asked, with Prophet, you're able to account for all the other aspects, and it's very close to, maybe there's a way to test this, the accuracy of this, but maybe we'll compare this graph sometime in future and we'll see. But yeah, so this is actually, it could be true, it might not be, but most of the time the machine learning doesn't fall off too far.
I think what I'd say, Kimani,
Yes.
is that, okay, I saw a quote somewhere. It says that all models are wrong, but some models are useful. Yeah.
Are
So
useful.
yes, some are useful, but all are wrong. So I think with real life events going on, I think it calls for a lot of recalibration at times. Say, for instance, if you're even doing a model on credit risk and you're advising companies on how to lend, borrower behavior changes over time. And sometimes it changes so fast that your model is left, it becomes irrelevant. So I think we have to, from time to time, recalibrate the model.
Okay,
so that
it's true.
Yeah.
I don't refuse, and that's actually the truth. So like in this picture, there is actually a scenario that I saw being asked. If so this is the way machine learning argues out. If your sister jumps into a river and your three sisters jump into a river, or maybe picture is three cows. Four of them, three jump into a river and they die, and what will the fourth one do? And you're using a machine learning model. What will the machine learning tell it? It will tell it to jump, right? Because it's based on history. So yeah, there's that as well. But anyway, but there are very many different things to look at and scenarios, but we've gotten through some of the basic part of it. I tried to make sure the notebook has all the, like, you'd be able, even when you're doing it on your own, you'd be able to go step by step and understand, see what you can do on that. And then, but any other question? Any question on how far we had gotten?
I guess it would be wise if maybe we go through the notebook.
Yes.
And see what we can, the challenges that we can encounter, so that the next session, the rescheduled session, will maybe raise them up if we have issues.
Oh, yeah, because also I think it also sometimes it helps to go through the content, like go through, especially like the theory part of something, and then we practice. Sometimes so I think we can do that and arrange for a short session to just finish up. Yeah, maybe Wellington, you can help boost KPLC.
The rain have stopped, so we hope things will be better for a while.
Yeah, so maybe like just other than the theory part we were discussing,
the coding part. You see, like where such a system will come in, you'd be able to predict such, especially like or the example we had given on predicting demand. So you'd actually be able to switch on a bigger support system prior to demand going up. Because I think right now, I think most of the companies are closing at 3.
Yeah, sure.
So maybe just everyone got home and decided to switch on the TVs and transformers have gone down. Such a system, it will help a lot. There are a lot of places. Other like now, from maybe the business point of view, there's always a worry of overstocking. Overstocking, like you might produce more than you need. So in those scenarios, it's always a loss. So I think Grace can, especially when you have product that expires,
Yeah.
you have to optimize how you produce. And having a really good or the perfect model for predicting how much you should stock is really everything. And like I said, it can be a deal breaker. And even like okay, those sometimes there are those I could call them like the black swans, like with the guys for sanitizer now. They never thought that one day they'll run out of stock. Like or like demand will be so high they can't even meet it. So yeah, but there are those scenarios, but most of the time with this kind of models, you'd be able to predict accurately what you need to do. And yeah, so it's pretty good. And then there's also the other aspect, now pointing back to the video we had watched. Do you see a scenario where machines take over all the decision making? And is it a good thing or a bad thing?
I think for me, I'm a bit skeptical. Like maybe not 100% of the operations. I still feel we will somehow need a human element.
I
But
think
a certain percentage.
A machine, yes. Will it be close to 90 or?
If you can remember, one of the links that was in the portal, the Predictive Analytic Lab, there was a track that was being taught on how to, to drive on its own.
Yeah.
And actually had a lot of judgment issues because it could not, identify the car that because there was a camera van running along with it, and it could not.
Yes.
It actually had a very hard time because it couldn't know that these are van that is supposed to be there to take the footage. So yeah, there are some decisions that actually needs a human intervention. Yeah, actually.
So it's a good question, but at the same time, I'd ask you this.
Yeah.
Right now in Kenya, there are around 10,000 people who are killed by accidents every year. In US, it's around 40,000 every year, as in it's like a repetitive thing. Yeah. Since we started doing the self-driving cars, they've been around 4 total accidents.
Okay.
So what would you say about that? Because you see, like, you remember what I said is, like when you now look at the math side of it, on the statistics side of it, like self-driving cars are reducing accidents by over 75%. 75. I think Alice can tell you, I've always told the students that a few years from now, driving will be legal. Do you believe that? True or not, driving will be legal.
Human beings driving will be legal.
Because you see, like, someone will see you and look at you the same way you see someone on a donkey. Because it's that dangerous, probably. Like, because you see, like, the same way some sometimes people look at like driving a motorbike with sandals and shorts and a t-shirt. It will look like that. Like people will ask, yani, you don't care about yourself or others or something like that. Because if you look, the statistics will be very clear. Like there's even a video I show that the cars don't, you see, when like the problem even with traffic today is cars have to stop every time, because I've seen a green light but I hesitated, so I stopped a bit. The one behind me had to brake. So you don't even see what caused the traffic, but there is traffic. Same. So like with smart farms, you have a machine that's deciding when to put water to a plant, the exact nutrients it needs. So it's a better farmer than any farmer that exists today. So basically, back to the point on, there might be a point where we get to machines making all decisions, because they make better decisions than us or any human, but they just need to be better than the best human that there is.